everybody, welcome to our next topic, unit arithmetic. Okay, so our previous topic, dimensional analysis, it's not going away. It's not going anywhere. It's always going to be there in the background. It's so important we had to start the course with it. What we're going to do as we move forward is we're going to continually build on that idea with new ideas. So here's our next one. And the idea of unit arithmetic is just to be able to scale things so they can be compared fairly. Okay, so let's jump in. The first one we're going to look at here is if something costs $24 per 12 ounces, how much does it cost per ounce? Okay, so in the reading you did above, you learned that per means fraction bar, per. A popular one you've heard of is percent, 100%, 50%, 75%. Per simply means divided, and cent means 100. So percent just means per 100. But that's only one. There are lots and lots, as you saw in the intro, tons of pers that you can use. So this one is $24 per 12 ounces. How much does it cost per ounce? Now I'm going to write the $24 a little bit differently to kind of show you a point here. We're going to write this as $24 per 12 ounces. I know that we often use a $24 with a little burn symbol, and we can put that in later. We probably use it moving forward. But the reason I'm writing it like this is I want to drive home a point about the math here. Now your job in a problem like this is to get this denominator down to 1 ounce. 1. That's the idea of the unit. Per 1 something. Or 1 per something. We'll get to that later though. So per 1 something. So the idea here is, if this wants to get down to 1, we have to get this 12 out of here. Now I'm going to show you, I think, the easiest way to do this. My personal opinion. If you don't like this way, you send me an email, we'll come up with a different one. Here's what I think is the easiest way. Divide the 12 into the 24 and see what you get. So if you divide 12 into 24, you get 2. So technically speaking, it's really 2 over 1, as we discussed in the last unit about dimensional analysis. But 12 goes into 24 2 times. That 1 represents the 12 that you divided into the 24. If you think of it in terms of fractions, 1, 2. The same thing we talked about last unit as well. So it's 2 over 1. But 2 what? 1 what? And that's where the units come along. They're still here. It's $2 per 1 ounce. So that's the answer. If it's $24 per 12 ounces, then it's $2 per 1 ounce. So all you have to do is isolate the unit, make sure you don't lose that unit, that's coming along with you, and then just do the math that's over here, 24 divided by 12. That's it, straightforward. That's unit arithmetic in a nutshell. Let's do some more. If a city encountered 45 crimes over the course of 30 days, how many crimes on average did it experience per day? Okay, I'm going to leave this one up here to kind of model off. How many crimes did it experience on average per day? We'll get back to the on average part momentarily. Let's focus on how many crimes did it experience per day. Crimes experienced per day. We have our unit. We have our unit. It's crimes per day. That's the unit. All we've got to do now is make sure we have the numbers right. How many crimes? Well, I think it said 45 crimes, 30 days. 45 crimes, 30 days. I'll put an S there because it's plural right now. But again, there's the unit. Crimes per day, or days. This isn't an English class. Don't worry about plurals and things like that. I think that's the right word, plurals. Crimes per day. All you got to do is divide the 45 by the 30. 45 divided by 30? That's 1.5, isn't it? That is 1.5 per 1 if you want to, but 1.5 crimes per day. There you go. You can also write it in English if you want. 1.5 crimes per day If you remember from the intro video, very often some of these units have acronyms like ppb for parts per billion or ppm for parts per million. That's a big thing in, like, especially with things like wildfires and other things, and then the coronavirus, measuring concentrations of things in blood. But anyway, I think personally, I'm not a huge fan of jargon. I like writing things out in words so it's super clear to someone reading. Like, for example, the river level that you saw in the intro video, cubic feet per second. If you tell somebody CFS, they might not know what you're talking about. So I personally would rather write the words out and make sure that everything's super clear. Okay, let's do some more. Okay, number 3, we're going a distance of 100 miles in 2 hours. What is your average speed? Miles per hour. This is a throwback and a reference to one of my favorite places on earth, Summer Lake, Oregon. It takes me almost exactly 2 hours, just about 2 hours to get from my house to Summer Lake, and it is almost exactly 100 miles, so this is a nice one. 100 miles in 2 hours, miles per hour. That's a famous rate. Famous rate. Miles per hour, MPH. You see it on your speedometer on your car. So we're going 100 miles per 2 hours. We've got the unit. Miles per hour. All we gotta do is do the math. So that means you're averaging 50 miles per hour. Yeah. It's pretty straightforward. It's always the same. All you gotta do is figure out what the unit is and get the numbers in the right place. That's it. It's pretty straightforward. It's not new math, it's division. But all you gotta do is make sure that your numbers are in the right place. Okay, let's try the next one here. There are exactly 2.54 centimeters in 1 inch. How many centimeters in a foot? Okay, so I stuck this one in because I want you to realize that dimensional analysis, as I mentioned before, doesn't go away. It just becomes part of a toolkit in which unit arithmetic is another tool. So we've got 2.54 centimeters in 1 inch, per 1 inch. This should look familiar to you from dimensional analysis. I mean, all those little fractions you would multiply by to be able to divide off units were all unit arithmetic fractions, so to speak. We need to get this to centimeters per foot. So I like sneaking problems like this in every once in a while because it forces us to go back and realize, like, okay, how are we going to do this? Well, something else you have to realize is there are 12 inches in 1 foot. So in order to convert inches to feet, we have to do our 12 inches per 1 foot. And this starts to look like a problem from last section, which is totally fine because these sections shouldn't be viewed as exclusive to each other. They tend to overlap. Inches divide off, and you're left with 2.54 centimeters per foot. All we gotta do now is do the math. So I'm gonna dive out of here, grab my calculator, and figure out what the heck 12 times 2.54 is with some kind of precision. 2.54, I get 30.48. So there are 30.48 centimeters per foot. But again, it's all about the unit. Centimeters per foot. Inches were just a sidebar, if you will. Cool? All right, let's jump into the next couple, get these last 2 done, and then move on. Okay, a scooter gets an average of about 90 miles per gallon. How many miles, on average, could you drive with it on 4 gallons of gas? Okay, so this is one of my favorite kinds of questions because students will often stop and ask me, well, I don't understand, is it 90 divided by 4 or is it 90 times 4? Okay, it's a great question, but it's the kind of question the units can actually answer for you. Let's start with what we know. We know the scooter gets an average of 90 miles per gallon. 90 miles per gallon. And I'll put a 1 in there if you want, per 1 gallon. Okay. How many miles, on average, we'll come back to that in a second, could you drive with on 4 gallons of gas? So think about what the question is asking you. How many miles could you drive? Not how many miles per hour could you drive, because that wouldn't make sense. Not how many gallons you could drive, because that doesn't make sense. As a matter of fact, if you think about the question, how many miles could you drive? Miles, that's a distance. So you want miles to be the unit in your result over here. Miles. But this is miles per gallon. So gallons gotta go. Well, if gallon is in the denominator down here, in this unit arithmetic fraction, we've got to get it out. That means we have to multiply it by gallons up here. Gallons over what? Well, gallons over 1, technically, because there is no over what. You can always put anything over 1. You'll probably hear me repeat that over and over and over again. So then the question is, I know this will work out unit-wise, because the gallons will divide off. But how many gallons? Well, that's the question tells you. 4 gallons. 4 gallons. And then, boop, boop, the units divide off. You're left with just miles, which is what you wanted. How many miles? Well, for every gallon, you go 90. You've got 4. That's going to be 360 miles per that 4 gallons. Hopefully that makes sense. Now, last question, and then we'll move on. Why did some of those say on average up there? So number 2, number 3, and number 5. I'm actually going to focus on number 1 and number 4 to draw the distinction and then come back to those. Something costs $24 per 12 ounces. How much does it cost per ounce? Assuming there's no weird deals going on, if you bought 12 ounces of something and it cost 24 bucks, then just like the kitty litter in the intro video, you can knock it down to an ounce and every ounce costs the same. So if you buy 1 ounce, it's 2 bucks. If you buy 2 ounces, it's 4. 3 ounces, it's 6, and so forth. Every additional ounce is exactly $2 more. Same thing as the centimeters and inches. Every additional inch is exactly 2.54 centimeters. The other one's the averages. Think about the city. 45 crimes over 30 days. So when you said on average it was 1.5 crimes per day, first of all, think about what 1.5 crimes looks like. Is that like you broke into the house and then you were like halfway to breaking in and then stopped? No, there's no such thing as half a crime. But if you were to take the 45 crimes and spread them out evenly per day for 30 days, it would average out, even out, smooth out to 1.5 per day. There's no such thing as a half a crime, but there is such thing as an average of half of a crime. And you'll notice that the 3 that have averages in them, crimes per day, average speed in miles per hour, and average of 90 miles per gallon, all of those are a long-term typical measure. So when you say, for example, the scooter averages 90 miles per gallon, that doesn't mean it always gets 90 miles per gallon. That means sometimes it gets more, sometimes it gets less. But the average, the typical, is 90. The same thing about you drive 100 miles in 2 hours. When I go to Summer Lake, there are certain stretches of that are going uphill, certain ones are going downhill, and certain ones are going flat. That means I'm not going the exact same speed all the time. On stretches I am, but there are sections where I stop, there are sections where I start. I mean, that average was 50 miles an hour. I don't leave my driveway going 50. I mean, that would be ridiculous, right?
Could be fun.
Completely ridiculous. But it averages out to 50. That means sometimes I'm going slower, sometimes I'm going faster. Sometimes more crimes are committed per day than other days. But the averages kick in when we talk about smoothing data. Hopefully that makes sense. All right, take a look at the next few and we'll regroup back here.